Right, so when you are solving simultaneous equations, right, in grade 10, what you have to do is you have to look at any one of the two equations and decide which one is the simplest. Okay, by simplest, we are saying you must look at whether x or y has a coefficient which is equal to 1. Okay, that will be the simplest of the two equations. So when you see the equations, I'll show you just now when I'm doing some examples, right? You must identify any of the two equations that has got an x or a y that has a coefficient which is equal to 1. Then you make that x or y the subject, or you solve for x or y in that simple equation. Then you substitute whatever you get in the simple equation into the second, right? I know that when I'm saying it, it might look like it's complicated, but it's not. But sometimes you might find that both equations may be complex, so in that case, you have no option. Okay? You just have to decide whether you want to solve for x first and then y later and vice versa. Okay? But generally, the idea is to identify the simplest of the two equations. Right? Now, there are two methods of solving simultaneous equations in grade 10. Two equations. In fact, I would say for you guys in high school, you only have two methods, right? The first method, which is the most common one, is called substitution. Okay? The most common method is called substitution. And you are going to encounter that going forward. And some of you are doing physical sciences, and you use that method a lot in physical science as well to solve whatever you solve in physics, whether it's velocity or whatever it is, then you use substitution. That's the most common method of solving a pair of simultaneous equations or a pair of equations. Then there's a second method which is called elimination, whereby you just eliminate one of the two variables so that you create a linear equation in one variable. Okay, that's the second method. I'll probably talk about that one later on. So let's start by solving a pair of simultaneous equations by using substitution. Okay, so I'm going to do an example just now. So just write heading, examples. Okay, I'm going to check the examples from Everything Maths or Siabula. Okay, so our first example, I'm going to do the following question. It's x plus y is equal to 8, and the second equation is 3x plus 2y equal to 21. Okay, so here we have got two linear equations in terms of both x and y. So if you want to solve for x and y here, what you have to do is you have to choose one of the two equations, okay, in such a way that it has got an x which has got a coefficient which is equal to 1, or a y that has got a coefficient which is equal to 1. So if you look at both equations, right, let's analyze them both, okay? If I started the first equation, I'll call this one my equation 1, and that one I'll call it equation 2, just to make it easier for me to identify them. Okay, so if you look at equation 1, the coefficient of this x, it's a 1. The coefficient of that y is also a 1. Now, that makes equation 1 a simple equation, which means I can easily isolate the x or isolate the y. We call that isolation of a variable, making a variable the subject, right? In the second equation, you look at the second equation, the coefficient of x there, it's a 3. The coefficient of y there, it's a 2. That means equation 2 is more complex than equation 1, because the coefficient of both x and y is not equal to 1 in equation 2. So to carry on, I'm going to make x the subject in the first equation. You can also make y the subject. It is your choice. Okay, I just decided that, okay, let me make my x the subject. So if I make x the subject, means I'm taking the y to the right hand side. Okay, so I'll end up having x equal to 8 minus y. Now, this new equation is actually equation 1. The only thing is that I made x the subject, so I can call it equation 3. But be aware that equation 1 and 3, they are exactly the same. It's just that they are written in two different ways. Okay? Then, when you get to this point now, the next step is to substitute equation 3 into equation 2. Okay? We're going to substitute equation 3 into equation 2. What I mean by that is, where there is x, you see this x here, right? The right-hand side is equal to 8 minus y. So where there is x here, I'm going to substitute that x here by 8 minus y, because I need to create a linear equation in one variable. A linear equation in terms of x only or y only. In this case, if I substitute equation 3 into equation 2, I'm going to create a linear equation in terms of y. Okay, so this 8 minus y is going to replace that x. So I'm going to write this down. Say substituting equation 3 into equation 2. Okay, we will get right. So if I substitute equation 3 into equation 2, equation 3 will become 3 times 8 minus y plus 2y equal to 21. Okay? So equation 3 no longer has x, because that x has been substituted by 8 minus y. Now, this will make it easier for us to solve for y. Okay? Then you end up having a linear equation like what we were solving at the beginning of the topic. Okay? So this becomes 24 minus 3y plus 2y equal to 21. Okay? Then minus 3y plus 2y gives me minus y. Then I'll take the 24 to the right. I'll get 21 minus 24, which gives me negative 3. And what this means is that my y is going to be positive 3. So I have solved for y. Okay? I'm not done. I also need to determine what x is. So I have to solve for x as well. Now, solving for x should be easier now. All I have to do is go back to equation 3. Where there is y in equation 3, I'll put 3 there. So it's easier now. Okay? So to solve for y, I'll go back to equation 3. It's x equal to 8 minus y. But my y is equal to positive 3. So my x is going to be positive 5. So I have my two answers. Okay? Those are my two answers. So y is equal to 3 and x is equal to positive 5. Okay, then but who has got a question? Then one who has got a question? They are following. Okay, let me do my time second. Okay, second example quickly. Right, I'll do a second example. Right, second example. So I'm going to do a second example that's a little bit more complex. All right. I'm just going to show you one way you can end up creating fractions. So I'm going to do this one. 2x, 2y rather. Just give me a second, I need to recalibrate my view. Alright, let's solve this one here. 2x plus 3y equal 5. And the second one is going to be 3x minus 2y equal to 4. So we're going to solve those two simultaneously. Right. The first example, right, one of the two equations, the coefficient of x and y, which was equal to 1. Now for these two, both x and y don't have a coefficient which is equal to 1, which means we have no way out. We have to create fractions along the way. All right? So I'm going to choose. Now, this time I'm going to choose equation 2. There is no special rule which says must choose equation 1. No, it depends with the situation. Now, for this one here, I'm just going to choose equation 2, just to show you that you can work it out that way. There is more than one way of doing it. So, in this case now, I'm going to choose equation 2. In equation 2, in the previous example, I made x the subject. Now I'm going to make y the subject. Okay? So if I want to make y the subject in equation 2, all I have to do is take the 2y to the right and then bring the 4 to the left. Okay? So if I do that, I'll end up having 2y is going to be equal to 3x minus 4. But before I wrote this, I got this, I want you to be aware that, okay, let me use a different color. Yeah. Okay, wait, because I need to write another step before this one because of that. Okay, don't worry. So I could have written it first as saying minus 2y is equal to. Now, I want you to be aware that, okay, there is more than one way of doing it, right? I can take the minus 2y to the right, it becomes positive 2y. Then I'll take the 4 to the left. So let me do it that way to avoid confusion. So all of you, I want you to be aware that before this one, which is in red, first take the minus 2y to the right. Then bring the 4 to the what? To the left. So if you do that, you get 3x minus 4 equal to 2y. Is there anyone who has got a question there? If you have any question, feel free to ask. Okay, Tyra, are you okay with that? Then, if 3x minus 4 is equal to 2y, it also means that I can write it as 2y equal to 3x minus 4 without changing any sign. Okay? Alright? You must know that by now. Okay? Or if you didn't know from today, you must know that you don't have to change the sign. I don't want to get into the details of the mathematics as to why the signs don't change. But I can prove to you that why the signs don't change. Okay, so I'm going to call this one here my equation 3. Okay, in fact, before I wait, let's not call it equation 3 yet. Let me make y the subject, right? I'm going to divide both sides by 2 to make the coefficient of y equal to what? To 1. So my next step will be to say 2y over 2 is equal to 3x over 2 minus 4 over 2. Remember, the objective is to make the coefficient of y or x equal to 1 for me to carry on. That's the objective. Okay? So this becomes y equal to 3 over 2x minus 2. Then this becomes my equation 3. So I now have my third equation. Okay? But you need to be aware that the third equation is exactly equation 2. They are the same, it's just that they have been written in 2 different ways. Alright? Then, from here now, I'm going to substitute equation 3 into equation 1. Okay? Please, you don't substitute equation 3 into equation 2 because they are the same. Okay? Don't make that mistake. Be aware that equation 2 and equation 3, these two are the same. So when you are doing your substitution, you substitute into the one which is not related to the third equation. And that equation is going to be equation 1. So, say, substituting equation 3 into equation 1. I'm substituting equation 3 into equation 1. So, where there is y in equation 1, where there is y here, I'm going to substitute the right-hand side of that equation. Okay? Where there is y there, I'll put 3 over 2x minus 2. Okay? So, if I do that, I'm going to end up getting 2x plus 3 times 3 over 2x minus 2 is equal to a 5. Now I'm creating a linear equation in terms of y. Okay? And it becomes like the question that we're doing at the beginning of the topic. That's why you have to know how to solve linear equations. Right? Then I need to simplify this. So to simplify it, I'll get 2x plus 9 over 2x minus 6 equal to positive 5. Okay? I'm going to carry on. Now, when you're doing a question like this, it can be a little bit long because of the amount of working out that is to take place. Right? So I'm going to move on to the next step. So here, I have to add the 2x plus the 9 over 2x. Remember, 9 over 2 is the same as 4.5. So I'm going to get 6.5 x on the left, which is the same as what? 13 over 2x. So I'll take that minus 6 to the right. That's the next step. So on the next page, I'm going to write it as 13 over 2x is equal to 11. Okay? If you add 2x plus 9 over 2x, you get 13 over 2x. Okay. Right. Look here. 2x plus 9 over 4x. First, you get 6.5x. If you convert 6.5x to an improper fraction, you will end up getting 13 over 2x. Are you following that? Okay, let me write that step to avoid unnecessary. So if I add 2x here, Right? Remember the denominator there, it's a what? It's a 1. Don't forget that. The denominator of this 2x here, it's a 1. What's the LCD of this part? Forget about the constant. What is the LCD there? It's a 2. Are you looking? Yes. You are sitting at the beginning to look. The LCD there of that of the first two terms, it's a what? It's a 2. So I'll multiply the 2x by 2. The 1 by 2. So you end up getting as your numerator for the first term is 4x plus 9x. That will give you 13x. Okay? All over 2. Are you following that? Okay. Then, so that's what I got. Right. Now, when you get there, you should not get confused. The denominator of that 11 is a 1. Okay? Then you cross multiply. Now, when you cross multiply, be aware that the improper fraction on the left, the x is part of the numerator. Okay? The x is part of the numerator. So, just to avoid confusions, I'm going to write it as 13x all over 2. This is going to be equal to 11 over 1. Then you cross multiply. So you get 13x equal to 22. Right? Then you divide both sides by 13. So you end up getting x equal to 22 over 13. So this is my value of x. Okay? You don't have to convert it to a decimal. Leave it as an improper fraction like that. Right? Don't try to convert it to a mixed number. It's not necessary. Okay? Now I'm not done. I need to find y. I found x, but I need to find y. Just to let you know from my experience, it's a common mistake that some learners will calculate x like how I did here. They stop there. They forget that you also need to find y. Okay? You are no longer in grade 8 and 9 anymore. So be aware that when you get two pairs of equations, you must get two values. One for x and one for y. Right. So for me to get the y value, I need to substitute this x, okay, where there is y in equation 3. So I'll go back, my equation 3, this one here, y is equal to 3 over 2x minus 2. So I'm going to rewrite it. Y is equal to 3 over 2x minus 2. Where there is x here, where there is x there, I'm going to put that 22 over 13. Okay? Where there is x there, I'll put that 22 over 13. So, if I do that, I'll get y equal to 3 over 2. I would advise you to put the 3 over 2 in brackets because our x is a common fraction or an improper fraction. That's 22 over 13 all minus 2. Right? Then we need to simplify this now. Now to simplify, okay, 2 into 22, that's 11. Right, so I can write this as 11 times 3, which is 33 over 13. Okay, so I can carry on here and write this y equal, but I'm just going to show you, or someone might say, how did he get that? 2 into 2 is 1, 2 into 22 is 11. I'm doing it without a calculator, remember. Right, I don't need a calculator. Right, so 3 times 11, that's 33. So I'll get 33 there over 13 minus 2. Right? Then my knowledge of fractions is required for me to carry on. The denominator of that 2 is a 1. The LCD is going to be 13. So I'll multiply the 2 by 13, the 1 by 13. If I do that, I'll get y equal to 33 over 13 minus 26 over 13. And this will give me y equal to, well, that's 7. Right? 7 over 13. So that's my y value. So I've got my y there and my x there. So both x and y are, well, you can call them common fractions if you want. Okay. So the second example is a little bit long because of the fact that the coefficients of both x and y in both equations are not equal to 1. Therefore, we have to create fractions and work with fractions. Okay. Then, but we have got a question. Right, if you don't have a question, then let me do one example on elimination, and then that will be the end of, okay, the introduction to simultaneous equations. I just need you to be aware that most of you are going to find that you are going to use substitution more as compared to elimination. Okay, and I encourage you to use substitution more than elimination. But it can be your choice. At that moment, if you feel that you want to use the second method, elimination, it's fine. So let's do substitution by elimination. So solving by elimination. Solving by elimination. Okay, what I'm going to do, I've got the question paper here from the department. This is the paper that you're supposed to write if you're written department paper. So I'm gonna do the question that's on this paper here. So some of you I gave you, but I'll give everyone at the end. Right? So I'm gonna do that, I'm gonna use it as, I'm gonna do that question as an example. So the equation is 4x minus 2y equal to 6. And the second one is 2y plus 3x equal to 8. Okay? All right. So those are the two equations. I'm going to solve for x and y using a method called elimination. Now, if I want to eliminate x or y here, my suggestion would be to rewrite both of them in such a way that the terms in x are in line. What I mean by that is, if in the first equation, okay, this is obviously equation 1, I can call that one equation 2. In equation 1, the equation starts with x, but equation 2 does not start with x. So I'm going to rewrite them as 4x minus 2y equal to 6, and I'm going to rewrite equation 2 as 3x, okay, 3x plus 2y equal to 8. All right. Well, let me change the name. I'm not gonna, I realize that I don't want to end up having so many names of my equation. So I'll call this one equation 1 and that one equation 2. All right. But the original question was like that. Now, if I want to eliminate x or y, I'm sure you can see here that for both equations, the coefficient of x is not equal to 1. Okay? Also, for both equations, the coefficient of y is not equal to 1. But by inspection, I can eliminate y. Okay? I'm sure you can see that in the first equation, we have got minus 2y. In the second equation, we have got a positive 2y. Okay? So what that means is, if I add minus 2y to positive 2y, I'll get a what? A 0. Alright? So here, I can add the x terms, I can add the y terms. If I add the y terms, I'll eliminate y. And then I can add the answers on the right, or the constants on the right. I'll end up having a new equation in terms of x, with no y. Okay? So, what we do is we draw a horizontal line because it's already simplified. Okay, this is the simplest case of elimination. Right? So what you do is I'm going to add equation 1 and equation 2. So what I'm going to do is I prefer to put the brackets here. Okay, I'll put the brackets in the second equation like that. Then I'll put a plus outside. Right? The reason why I'm putting that plus it's an indicator that I'm adding the two equations to eliminate what? 1. Right? So when I do that, 4x plus 3x will give me 7x. Okay? Minus 2y plus 2y will give me what? 0. 6 plus 8 will give me a 14. Sometimes you may need to multiply both equations by a certain factor. Okay? Like for example, if I wanted to eliminate x here, okay, I have to multiply equation 1 by 3, equation 2 by 4. Okay? Then I'll subtract the two equations to eliminate x. Are you following that? I'm going to repeat that. If I wanted to eliminate x here, I would have to multiply equation 1 by 3, equation 2 by 4. Because remember, the LCM of 4x and 3x is a 12x. The LCM of 4x and 3x is a what? 12x. So I have to multiply the 4x by 3, the 3x by 4. Once I do that, I'll create 12x in the first equation, 12x in the second equation, and then I have to subtract the 2 and get 0, right? But the y won't be eliminated. Then I'll be able to solve for y. That's another way. So this one is the simplest case. So the next thing here is to solve for x. So I'll just divide both sides by 7, and I'll get my x is a 2. Okay, so x is 2. Okay, once I find the x, then I have to choose now among the two equations, whether it's equation 1 or it's equation 2, whereby I'll substitute the x into any one of the two and solve for what? For y. Now I'm going to choose equation 1. So equation 1 says 4x minus 2y is equal to 6. Since x is equal to 2, where there is x, okay, I'm going to put 2, so it becomes 4 times 2 minus 2y equal to 6, and that will give you 8 minus 2y equal to 6. And then you get minus 2y equal to minus 2. Alright? Then my y, obviously, minus 2y over minus 2 is going to be equal to minus 2 over minus 2. So you get y equal to 1. And you can test these answers, right? You can test them if they are correct. Let's just do a quick test quickly, right? If you go back to equation 1 here, if I put x equal to 2 here, I'll get 4 times 2, which is 8. If I put y equal to 1 here, minus 2 times 1 will give me minus 2. 8 minus 2 gives me 6. Okay? So sometimes you might need to check your answers too. If your answers are correct, then they will make the equation a valid equation. Okay? So this is elimination. I feel like I have to do a second one on elimination. Right, let me look for another example. Okay, let's do this one. So it's 7x plus 3y equal to 13, then 2x minus 3y equal to minus 4. Okay, doesn't look like what I want. But just allow me to alter it a little bit. Okay, allow me to. So I'm going to change the coefficient in the second equation. Right. So this would be minus, let me say, minus 4y equal to, okay, maybe 12. Okay. Now, if I want to solve these two using the elimination method, all I have to do is I have to decide whether I want to eliminate x or eliminate y. Okay? I'm going to eliminate x. Okay? Now, for me to eliminate x, I need to make this 2x equivalent to the LCM and the 7x equivalent to the LCM. Now, what's the LCM of 7x and 2x? It's 14. So in that case now, I will multiply equation 1 by 2. Okay, I could have named it. Okay, let me name the first equation. So this is 12. Right? I'll call this one equation 1. That's one equation 2. I'll multiply this equation by 2 and the second equation by 7. When you multiply by the 2 and the 7, you multiply both sides of the equations by that constant. So this one here becomes 14x plus 3y times 2 give me 6y equal to 13 times 2 give me 26, right? And then equation 2 will become 14x minus 4y times 7, I'll get 28y, then 12 times 7, that will give me 84. Okay, now I can call this one here my equation 3 and that one my equation 4. So I have created two equations based on the multiples of or rather the lowest common multiple of 2x and 7x. Right? Now, I'm sure you can see now that I can eliminate x. Right? How am I going to eliminate x? All I have to do is subtract equation, subtract here, I'm going to subtract equation 4 from equation 3. So I can put my minus here, open my bracket there, and do it like that. Right? Once I do that, then it will be 14x minus 14x, that's 0. Then 6y minus 28y, I'll get 34y. Then 26 minus 84, right? 26 minus 84. No, this is minus. Okay. 6y minus, remember we eliminated x. We are trying to eliminate x. So I have to put a minus here. I have to subtract equation 4 from equation 3. 14x minus 14x gives you a 0. Okay? Then 6 minus 28 gives you positive 34y. Then 26 minus 84. If I subtract 24 from 84, I'll get 60. Then I subtract 2, so that's 58. So this would be minus 58. Right? Okay? Are you following? Please don't come out of this lesson and say, but I didn't understand what he did there. Ask now whilst we're still here. Alright, now we can solve for y. Divide both sides by 34. So we'll get y equal to, right? I can simplify this. Please allow me to write it to its simplest forms, okay? So that will be minus 29 over 17. So that's the value of y. Okay? I've used elimination. Now I need to find the value of x. Okay, because the coefficient of x is not a 1, the coefficient of y is not a 1, the equations are a little bit more complex. I'm going to choose equation 2. Now, to find y, you can either use the new equations, but I don't encourage that. I prefer use the original equations. Is that clear to everyone? Use the original equation. So I'm going to use equation 2. Okay? If I use equation 2, remember I want to find what? X. So it will be 2x. Okay, 2x minus 4y is equal to 12. But I want to find x, so this becomes 2x is equal to, well, I can write it as 4 times this answer here. If I take the minus 4y to the right, I'll get a positive 4, so it'll be times this minus 29 over 17 plus 12, right? Okay, 4 times minus 29, that's 58 by 2, that's minus 116 over 17 plus 12. That's equal to 2x. Then 2x will be equal to. So can someone just simplify that for me? 12. Huh? The right hand side. 88 over 17. Then we want to solve for what? Remember, we're solving for x. So if I divide both sides by 2, okay? If I divide both sides by 2, okay, let me use this color. If I divide both sides by 2, it will be like this. X will be equal to 88 over 17 divided by 2, like that. Which means I can remove the division sign and swap the 2 and the 1. So our final answer for x, okay, our x, that allow me to write it somewhere at the top there. So our x is going to be equal to 88 over 34, which is the same as, if I put 2, so you get 44 over 17. Okay, right? And then we are done.